Hello everyone, my name is Tushar Rana and I am from IIIT Sricity and I am a second year undergraduate student doing CSE from BTech. Okay, so today we are studying our chapter number, it is the last chapter almost of physical chemistry, that is analytical chemistry. Okay, let me open my drawer first, both side. Okay, so today we will study analytical chemistry. Okay, some of the students have heard about this term, and if not, we will do a quick theory part. And after that, as you know that in this lecture, half time we study the theory part, and half time we do the numericals, which were asked in the previous years for JEE-Mains. Okay, so let me write down the heading first. Analytical chemistry. Okay, so what does the term analytical chemistry means? So as we have seen that in the chemistry, there we perform many chemical reactions, many mixtures we perform, we do many precipitation reactions, test tube reaction, and many types of reaction. But how do we know that that type of reaction are good or bad in the sense by quantity wise or quality wise? I mean to say that we are doing performing a certain reaction, so how much the product is formed? We say that this much product is formed in vast amount or a less amount, but how it is in quantity and what is the quality of that product? So here we study mainly this type of. Okay, so in this slide part, I have also written something. So let's see that. Okay, chemistry is a branch of science. Oh, it is some intro part. There are different branches to chemistry. Okay, uh, we all know that in organic chemistry, inorganic chemistry, and physical chemistry. See, these three types of part we all knows, we study in the chemistry. We are divided the chemistry in three parts: organic, inorganic, and physical. But one more part of the chemistry is analytical chemistry. Okay, so what does the analytical chemistry says? Chemical analysis is the, okay, it is hidden by that picture. Quality, the thing is that quality and the quantity of this substance. Okay, in chemical analysis we does not concerned about that quality and quantity. Okay, but in analytical chemistry it is concerned with the chemical characterization of matter, both qualitative and quantity. Okay, so what it is saying that when we are performing any chemical reactions, we just do the what is the reactant and product formation and like that. But in analytical chemistry, we analyze all the parts, like how much it is formed by mole or by quantity wise, and we also observe the quality of that product. Okay, so this is that. Just it is an intro part. I am skipping this one. Okay, it is showing some of the uses. Analytical chemistry in medicine. Yes, medicine also requires the proper dosage and the quality also. Industries, environmental quality, nutrition value of the food. It is determined by the chemical analysis of major components such as protein and carbohydrate. You have noticed that in many, like in protein bars or let's take a simple example of a dairy milk chocolate only. There at the last, at the wrapper package, there is a table containing here the nutrition value, and it is the how much that is weight in grams or milligrams. Okay, like that. So you have seen that. So that type of table also shows us the analytical part of that substance. Okay, so the analytical chemistry is basically divided into two parts, which were that. See, analytical chemistry, we divide it into two parts majorly. First one is that quantity wise, quantitative, and second one is quality wise. So I think you are now concerned what I'm trying to say. Now, if we check the first, okay, we have the differentiation table also here. So just look at there. Uh, Qualitative analysis deals with the identification of the elements, ions, and compounds in a sample. Okay, we may be interested in the whether only a substance is present. Okay. So in qualitative analysis, we generally measure the quality of the substance which are formed or which were reacted to form that substance. Okay. So here we identify the elements or ions it is forming, like if it is forming negative ion, cation, or any chemical changes like that. Okay. Example: elemental analysis, identification of sample structure to be analyzed. Okay. Now, if we move on to the quantitative analysis, it deals with the determination of how much. See, it is just these two words which are describing that quantitative analysis of one or more constituent is present. Okay. There are two kinds of quantitative analysis: chemical analysis and instrumental analysis. In chemical analysis, it is trying to say if we are performing any certain chemical reaction and we are measuring by the mole per mole reaction or any balancing equation. Or second method is instrumental analysis. We use some of the instrument, as you know that the science is moving towards forward. We have many instrument to analyze the how much product is formed or how much reactant of same type is used. Okay. Now, qualitative inorganic analysis. It is the analysis that is detection of the action cations anions present in the given compound of salt mixture. Okay. Now, let's move on to the next one. Identification of anions and cations. Okay. In basically the reaction part, we generally check how many cations or anions are formed. Okay. So we can predict what are the chemical properties or basically in qualitative. Firstly, I will say, okay, listen. Firstly, we are studying in this first part we are studying qualitative inorganic analysis. Okay, qualitative, and it is inorganic means chemical reaction will be occurring here. Okay, now let's move on. This is just intro part. Now, in the qualitative analysis of these reactions, we generally classify that one into the anions. As you have seen that identification of anions and cations. Identification of anion cation is done through a test of series, broadly divided into first preliminary test and second is confirmatory test. Okay, confirm the presence of cation or anion in the given compound. Okay, provides us the idea of the cation. Okay, see, these are the plain. Okay, you may have heard about these terms earlier also. Now, let's move on to the classification of the anions. Anions are classified by the two different modes. First one, okay, here written same times. Okay, let me change the marker color. It is blue only. Okay, red will be okay. Or maybe I can check. Okay, green. Okay, this one is B. See, first one is according to the identification by the volatile products. Volatile products means which reacts very fastly, like HCl or H2SO4. We generally take this acids, highly reactive acids, but not concentrated. Dilute HCl or H2SO4 because with concentrated it will react and no substance will be formed almost. Gases or vapors evolve with concentrated H2SO4. Okay, and some miscellaneous groups. Now, second one is according to the identification of the reaction in the product in the solution. Okay, we can check the reactions of the solution which are forming also, like if it is forming any PPT or any oxidation or reduction or any redox reaction occurs or any oxidation state change occur. By that we can also check the presence of cation or anion. So we generally need to check the presence of cation or anion. Okay, so here are some of the methods like group 1, group 2 and group 3. Okay, so if you want to check the anion is there or not, so we will be requiring some of the compounds which will contain that group. Okay, so we need to add some reagent or do some certain chemical reactions or perform certain methods to ensure if there is cation or anion. Okay, so firstly we are talking about anion here only. So if we have mixture of many anions, we add dilute HCl. We are using that strong acid method only. Okay. Now, for first group, it is volatile gases. Second one is that colored vapors, and third one is sulfate phosphate. Okay, we will come to the third one later. Now, in the first one, it will come reagent of that carbonates, hydrogen carbonate, hydrogen carbonate, sulfide, thiosulfide, sulfide, nitrite, cyanide. Okay, let's move on to the direct part. I will tell you. See, like here. Okay, here it's also written. This is group 1, carbonate, hydrogen. These are the anions in that group, and we use the reagent dilute HCl here. And the gases which will be evolved or PPT evolved will be this. You can read it. Similar for the second term, chloride, chloride, bromide. Okay, here mainly comes the HCl part, or HCl, sorry, halides part. Chloride, perchlorate, permanganate, organic ions. Here we use concentrated H2SO4 and HF, HCl, HBr, HI. Like this of the PPT or gases are involved. Now, if we're on talking to our the miscellaneous product, that is phosphates and phosphates, we have the reagent BaCl2 in our picture, and the gases or the precipitate which are formed, that is the BaSO4, Ba3PO4 whole twice is a PPT. So according to this, we will see how what are forming, what are the reactions occurring, and on to that basis we will ensure that we have cation or anion in our groups. Okay. Okay, we have analysis of group 1 ions. Let's see. Okay, I will not discuss all the parts. I will discuss, okay, first I will discuss only dilute HCl part only. I have provided the extra details also so that you can refer this one also. Okay, now if we have a CO3 2 minus mixture, okay, now on adding the dilute HCl SO4, sort of, sorry, dilute HCl, the effervescence due to the evolution of CO2 gas. As you know that if HCl will react with the CO3 2 minus anion, okay, see, this CO3 2 minus ion will not be readily available to us. It will be available to us in form of certain mixture, like it will form any H2CO3 or Ba2CO3, like that. Any other elements are mixed with this CO3 2 minus ion. The major funda is that we will have CO3 2 minus anion in that complex. Okay, now how to check that it is present in our compound or not? Effervescence due to evolution of CO2 gas which renders the lime water turbid. Okay, this will occur in the chemical reaction, and the chemical reaction which is occurring is given here. Okay, this one is not visible, I guess. Let me take something darker. Okay, black one is will be okay. See, we will see here equation CO3 2 minus plus 2 times of H plus that due to the um, hydrogen, or sorry, water. Now CO2 will be evaporated and H2. Okay. Now when CO2 will react with the COH whole twice that is present in the lime water, that is present in the water, that is lime water, CuCO3 will be formed and H2O will be also formed as there it is only there. Now like that we can present see that as CuCO3 is forming, so CO3 2 minus conformation is there. Now on taking about SCO3, similar to the previous one, it also do the same time of just H and CO3 not making some certain that much difference. The chemical reaction which will occur, that is SCO3 minus plus H plus, CO2 will be released at one end, okay, and H2. And now CO2 will react with CaOH whole twice, okay, and it will also form COCO3. So similar to the first one, it is okay. Now SO3 minus. Now what will occur with the SO3? Evolution of SO2 gas will be characterized by its suffocating odor. Okay, so if we want to ensure that if there is SO3 2 minus anion or not, we will add that dilute HCl, okay, and we will see that evolution of SO2 gas. Okay, so how we will see that the gas which is evolved is SO2 or not? It will show, it will give some suffocating odor of burning sulfur, which turns acidified dichromate. Okay, so we will use some acidified dichromate, and if it will pass, and when we pass that SO2 gas or any type, any gas which is released, as we don't know na, is there is SO2 or not in the previous, so we will pass it to the dichromate and the paper will turn to green, then it will confirmly tell us that it is SO3 2 minus anion present there. If not, then okay, see, SO3 2 minus 2H plus SO2 gas will be released. Let's see, we don't know. Okay, it is the chemical reaction which is occurring in that confirmatory test. Now SO2 will be passed to the dichromate acidified, that is H plus medium. Now this 2 times of chromium plus, so you have noticed that the here the oxidation state also changes of chromium anion. Okay, chromium ion, so it will turn to the green, so it will also ensure that there is the presence of SO2 gas, sorry, SO3 2 minus ion. Now similar to like that one, you can check for H2O3. I have provided the table with all the details containing the chemical reaction and what are the chemical changes occurring in that confirmatory test. Now if we take the example of NO2 minus, as we have taken for sulfur, here you can say that the lead acetate paper black. Okay, so here we check that BP PBS, the black PPT is formed, so it will confirm us about the H2 minus anion. Now, I will not tell all this, just repeating this doesn't mean not. Okay. Now we will come to NO2 minus, pale blue liquid plus evolution of NO2 brown fumes. This will be formed. How we will check? NO2 minus plus HNO2 will be formed. Now, HNO2 will react and form HNO3, that is a nitric acid. Now, on adding that NO, which will be produced, okay, and then when reacting with the available oxygen, it will give us a NO2 brown fumes. It is a brown fumes. As you know that NO2 is brown in color. So it will also show about the conformation of that NO2 minus anion. You can check this one also for same anion, which we have seen that, but here the reagent is changed. Like here we are using the BaCl2 reagent. In that we are reacting with that HCl. Now it is that pink colored phenolphthalein test, colorless solution, alkaline solution. Now AgNO3 reagent, when we are taking AgNO3 reagent, it will give this one. It will not give like that. Okay, if you asked a question about SCO3 minus will react with AgNO3, then it will give negative test. It will not show any reactions. Okay, so like that you can check. Like here also, S2 negative and NO2 negative will not give any reaction with the BaCl2. So simply like that. Here is also some special test I have given here, like blue ring test, brown ring test. Okay, you already have heard about this, and if not, just read it because this one is very important, I guess. I will talk about this one also. This one only. FeSO4 25% plus dilute SeSO4 or acetic acid plus NO2 minus anion. This one anion which we are checking, which is present in the solution. Now, solution slowly down the side of the tube. At the downside of the tube, it form a brown ring complex, brown ring formation temporarily at the junction of the two liquids. So it is the this is the formula. Okay. So this will show that there is NO2 minus ion present by this brown ring test. Okay. Now moving on to the anion groups. Now to the anion groups we have fluoride F minus, chloride minus, bromide, iodide, NO3 minus, ClO3. Okay, this one is the same. Perchlorate, ClO4 minus. Now permanganate, organic anions. So MnO4 consists in the many oxidation states. So we will may occur difficulty of checking which anion is present. Okay, we will see that. Now, taking about the NO3 minus. NO3 minus is the one of the most toxic environmental contaminant that causes great risk to the. Okay, these are the some physical properties or some chemical properties related to this one. So you can check this out. We will move on to the analysis part. Like here is something written: potassium halide are used as a sedative. Okay, if it may also ask in your exam that what type of compounds are used in the sedative. So you have to write that potassium halides. Okay, for what? Like example, on bromine minus ion, anion, it is used for sedative. Okay, see, hypokalemia. It is a type of disease. The antithyroid, antiseptic. Okay, that disease cure. Okay, the medicine which are formed for this related diseases uses this type of anion. Okay, so it can be asked like that. Now, analysis of group 2 ions. What are we are referring to group 2 ions? That is simply fluoride, chloride, bromine, iodine, NO3 minus. Okay, now here the anion complex changes. Now, concentrated here we are using, as we have seen that in group 1 we use diluted HCl. Okay, but here we use concentrated H2SO4. So what will be there here to check the presence of the anion, like chlorine, bromine ion? Similar to that one, we will perform certain in that chemical reactions in that conformity test. They will perform certain reactions, and on checking the PPT or some gaseous or some physical properties, it will confirm us about that anion. Okay, let's see about the fluorine minus anion. evolution of colorless corrosive H2F2 gas, which, okay, this one is the corrosive gas. Corrosive gas, I mean, you will understand what I'm trying to say. Like if it is in bring in contact with some metal or some iron, it will corrode itself, but not directly. It will take some time. Which turn, okay, and now it is given that which turns the blue litmus paper red, and the, okay, we can check the presence of fluorine minus in using the litmus paper too. Okay, and the test tube acquires a greasy appearance due to the action of the glass gas on the silica of the glass. Okay, okay. So you may have understood what I am trying to say. Okay, like if we have a test tube, okay, and if we have here some anything, let's take an example like any XF I am taking compound. Okay, so here it is fluorine minus ion. Okay, now we react with concentrated H2SO4. It will go certain any chemical reaction, like here it is written 2 fluoride minus ion with H2SO4 giving you H2F2 gas. Now H2F2 gas on that test tube glass, there is, as you know, that glass is formed of silica. Its chemical formula is SiO2. Now, when this SiO2 will react with this XF2, or some reaction will occur due to this one, okay, like H2F2 gas will be evolved. When it will react with that silica, it will form SiF4. Okay, it will give something of greasy appearance. Okay. Okay. So, not directly, because there will be some water substance also product. So its product will form some greasy appearance. So we can confirm that presence of that fluorine minus ion. So we can also check using the litmus paper also, as it is written. Now, for chemical, oh, so sorry, for chlorine, evolution of HCl, as you all know, and all have also um, make an idea about that. We can check by the HCl gas. Okay, evolution of HCl gas with its pungent odor turns the blue litmus paper red. Okay, forms. Okay, we have many properties of that HCl gases, so we can check that. Now, coming on to bromine, evolution of orange red fumes of HBr. Here, orange red fumes. Okay. Now, here are some chemical reaction according to that, similar to like that, but just we have to perform the reaction according to the reagent we have given. Now, for iodine, evolution of violet vapors. Here, orange red vapors. Here, violet vapors. Okay, like that. Now, for NO3 minus, evolution of NO2 red brown vapor, similar to that group 1 test. It is also forming brown SO4 2 minus and will form brown fumes. Okay, like that. Now, there are some or more reactions, like with AgNO3 reagent, fluorine will not react. With lead acetate reagent, it will also not react. NO3 minus ion will also not react, and this will also not react. So you can make a table and keep in mind that the first and the last will not react, and the chlorine, bromine, and iodine will react and give the test. Now, about chlorine, it will form curdy white PPT of AgCl. It will form curdy pale yellow PPT of AgBr. It will form curdy yellow PPT of AgI. You can just remember the color only. Forget about that chemical reaction. I think you can easily write the chemical reaction. Now, what about the lead acetate? That is Pb plus 2 ion. That chlorine will form curdy white PPT. Okay, in the both cases, it is forming white PPT. Now, for bromine, here it is forming pale yellow. Here it is will form white crystals. Okay, not PPT, white crystals. Now, here golden yellow. Okay, like that you can remember in your mind. Now, there are some important tests or some named reaction or famous reaction. Like this one, I will not say. It was just from the chemical reaction only. It is understandable. Now, if you talk about a chlorine, that is chromyl chloride test. So I will mark it 3 times because it is very much important. It can be asked so many times. Okay, so I will ask. I will discuss about this one only. Now, chlorine minus ion, solid. It will present in solid form. Now, on reacting with the dichromate, okay, and it is as concentrated as H2SO4. So I mean it is acidified dichromate. Okay, so Cr2O7 and 2 minus plus we are hitting some spot, and it will give us Okay, let me take highlighter. Red vapor of chromyl chloride gas, that is CrO2 Cl2 gas, which will form yellow solution of CrO4 minus on passing with NO solution. Okay, so I have not told you about any chemical reaction still now to learn, but for this let me write here chromyl chloride test. Okay, so for this chromyl chloride test, you have to learn this chemical reaction. Okay, chemical reaction, learn. Okay, you have to learn by any means, or it is mostly understandable only if we pass Cl with acidified Cr2 minus with this is the acidic medium, and we heat somewhat, it will form CrO2 Cl2. So it will ask a question, what is the color of CrO2 Cl2? Then you have to say that red vapors. Now on this passing this CrO2 Cl2 on that NOH any basis, it will form CrO4 minus. Okay, and it forms a yellow PPT, yellow PPT. Okay, so it will confirm the presence of the chlorine minus ion. Chlorine water test, we can also perform the chlorine water test for presence of bromine. Okay, Cl2 plus bromine ion, Br2 plus Cl minus ion. This will these are the some chemical changes, and some colors also form. Okay, so in this way you can discuss about the group 2 element anions. Okay, let me take a new page. Okay, so I'm not discussing about that miscellaneous product, mainly about that, and now we will see about some halides. Okay, today this color is not good. Okay, okay, red is always better. This group contains fluoride, chlorine, bromine, and iodine. Okay, not NO3 minus, NO3 minus not. Only this one, only halides we are talking about. So here are written something about halides, so we will not discuss about that because it is not our inorganic part, and I think that you all know about what are halides and what are its chemical properties. I'm just discussing about this. These are the order of stronger halogen acid. Okay, this is the acidity order, and you all know that electronegativity order decreases like this. Okay, now let's see. Now, when we will react this halide with our concentrated H2SO4, so it will form 2 times of HX plus SO4 2 minus ion. Okay, so X may be Cl or I or Br or fluorine, anything. So it is also written decomposition of the halide occurs upon the addition of the strong non-volatile. Okay, many things. Now, fluoride gives a characteristic reaction when treated with the concentrated H2SO4. Okay, we will just jump onto the chemical reaction part. Like if we check the fluorine anion with the H2SO4, it will give HF gas. Okay, so it will also, we can check if someone knows about the HF gas properties. So we can directly see here. Now, if HIF gas is reacting with the glass, as we have seen in that example, SiF4 gas is PPT will be evolved, and this is a salicylic acid, and on it will react with the hydrogen, it will form H2SiO3, and you know that that is greasy substance appearance, which we have seen that. Okay, so like that. Now for chlorine, it is real 2 times of Cl minus plus H2SO4 giving you HCl plus SO4 minus. So this HCl will give us about the chlorine minus anion. I am just discussing about that one topic only. Just it is a somewhat brief intro. Okay. Now formation of white fumes with moist air due to the formation of droplets of hydrochloric acid. Yes, if the hydrochloric acid will form there. Okay, and it will react with the droplets of that moist air also. And pungent irritating odor. Okay, as it is a hydrochloric acid, so it will have a odor of very irritating. Okay, changing of blue moistness. Okay, here litmus paper also turns blue to red. Formation of white fumes of NH4Cl when a glass rod motioned with the ammonium hydroxide solution. So here it is chemical reaction, NH4OH plus HCl giving you NH4Cl plus H2O. Okay. Now, on talking about the bromide, a mixture of HBr and Br2 may be formed, which have a characteristics brown color. So you have to check brown color, especially on warming. At the same time, sulfuric acid will be reduced to SO2, H2S, and S. These are the byproduct. You may skip this one, but for if it is asked other byproducts which are formed, so we can check about which gases evolved. So we can say that SO2, H2S, or sulfur is found on reacting the Br with the concentrated H2SO4. Okay. Now, these are the chemical reaction. Bromine plus concentrated H2SO4 giving you 2 times of HBr reaction, which is that brown color. And SO4 minus ion will be, okay, this one, this is talking about that one only. Pr2 gas will be released. Now, SO4 minus ion will be reduced to that SO2, then H2O2, and some byproduct H2S and sulfur will be formed. So you can check like that. Now, talking about the free halogen, some more halogen part, like only not any like that HX, HX like HF, HCl. Now we are talking about X2, like Cl2, Br2, okay, I2. Now, uh, the presence of that free halogen, we want to, if you want to check that there is not an ion, we want to check just free anion without any anion, like if there is Cl2 gas present or Br2 gas present or I2 gas present. So what we can do first, bleaching of moistened colored litmus paper. Okay, if there is a free halogen, then it will bleach the moistened colored litmus paper. Now, suffocating and irritating odor, as it is halogen gases, so it will give us a very irritating and suffocating odor. Now, characteristic color, brown shoes. Okay, you may have also seen in many parts, in many textbook also, there is written like color related to it. I'm writing this one because you have to learn this one, or to that lights, that is bromine, brown, iodine violet, Cl2 greenish yellow. Okay, I2 star changes paper. Okay, this one. Okay, you can check this one, or you may have learned also. Now we will jump onto the, we are just seen the qualitative part. Okay, now sorry, qualitative part of that inorganic. Now qualitative part of inorganic, qualitative organic analysis. Okay, sorry. So what we are seeing here, we are taking the organic reagent, not we will take elemental form. Now, reaction with alkanes. Okay, on alkanes here, when we will react alkane with the bromine, it will form this reactions, like if we have this one product. Now, some the upper half will contain alkane layer, water, and alkane decolorize bromine in the light, and it is that color. See, this color is there and this color is there. Okay, so you can see some test tube changes there. Now, reaction of alkenes with the bromine, that alkane reacted, but with alkene, it will decolorize the bromine into both the dark and the light. In both dark and light, it will decolorize. See here, orange to it is almost decolored. Now, if we will check about the reaction of alkenes with potassium magnet, that is magnets 7 Mn. Okay, let me change the color again. Okay, Mn plus 7. Okay, here we are taking Mn plus 7 anion. So Mn plus 7 anion, Mn plus 7 anion is reduced to, sorry, it is cation. It is reduced to plus 2. What is that? Mn plus 2. So how it is doing? That alkene decolorize the acidified magnet 7. Okay. So now, if there is insufficient alkene, we are giving sufficient alkene in the previous case, but if we are giving alkene due to some less extent, then the intermediate brown manganese will be formed. That is what we have seen, like Mn plus 7, Mn plus 5, and Mn plus 2. Okay, this was the oxidation state. This was in the sufficient conditions. Sufficient. Okay, sufficient, but in insufficient condition it will form the intermediate product. Okay, insufficient, and the color related to this is given, this is brown. Here we are seeing light pink, and it is almost decolored. Okay, so you can check that one. Now, this some reaction with the alkenes with the manganese, like that given, that if a reaction of alkenes with magnet occurs, that is manganese 7 only, then there will be no decolorization. Okay, because they are saturated. As you know that na, ki, if you talk about unsaturated part, saturated organic compounds, So it will contain only, just wait a minute. Okay. So if we talk about unsaturated organic compound, it will contain alkenes, alkynes, okay, like that. And about saturated hydrocarbon, we talk about alkene only. Okay. So like that. Now, reaction of haloalkanes. Okay, we hear a haloalkane comes. So on haloalkane reacting with the silver nitrate, it will give colorless solution. Okay, like that. This one is colorless, but with chloroalkanes, there will be a dark PPT, which will come in on exposure to bright light. Okay, these are the some more reactions you can see. I've just taken for showing you how the chemical reaction on the organic compound takes place. Like if we see about the alcohols, alcohols give effervescence with the sodium. As you know that what is sodium? Sodium is a very highly reactive metal. Okay, so this is because they're very extremely weak acid. Okay, now hydrogen gives a pop with the lightened splint. So that alcohol contains hydrogen gas also. So on reacting with that sodium, it will give a pop sound also with a light and spark maybe. Okay. As you have seen in many YouTube videos that on throwing the sodium in the river, it sparks. These are the some primary, tertiary, and secondary color combinations which are occurred or changed in that. We will discuss that later. I have something more for you now. Let's take a new page. Now we will talk about quantitative analysis. What is quantitative analysis? Here we will talk about the how much product formed or how much product is remaining. Okay. Now let's do the intro part. A technique for determining the concentration of a solution by measuring the volume of one solution needed to completely react with another solution. Okay, you understood this term. Now, okay, here it is all black. I noticed. Titration process involves addition of solution of known concentrate from burette to measured volume of analyte. Okay. Now, principle of titration. What are the for why we are using that? And what is the funda behind that titration which we are doing? You have heard about titration term in the redox reaction and that ionic chemical equilibrium chapter only. Okay. Now, it is based on the complete chemical reaction between the analyte and the reagent of known concentration. We will have the concentration related to the reactant and product. Okay, so that is analyte, and this is the titrant. We use this titrant to analyze what is the concentration of this product. Okay, so this all comes with relationship related to each other. Okay. What is analyte? Analyte is the solution of the unknown concentration but known volume. We will have the volume known, but the concentration will be unknown. Now, titrant, the solution of the known concentration. Here we will have the concentration of the titrant. Now, we will see the standard solution first. A solution of known concentration is called standard solution. We will have the concentration, so it is standard solution. So as you will also have notice or think that for secondary solution, it will not have concentration. Now, types of standard solution. Primary standard solid, it has certain properties, extremely pure and highly stable and can't be weighed easily. So as it is a primary standard solution and it is a pure. So you may also notice that if it is a pure, so it will require many measures, many correct mm, anything I can say that correct methods, correct order of that apparatus which we are using. So we should be able to easily calculate what is the concentration or what is the weight of that substance which are there. Okay, example Na2CO3, KHP. Okay, now second is standard. It has certain properties, less pure than the primary standard. Okay, less stable and cannot be weighed easily. So like that. Now we will talk about equivalence point. What I mean by equivalence point? So you know that point where if we are performing any certain chemical reactions, that titration reaction, then the point where the amount of two reactants are just equivalent. What I mean to say that if we have the reactant A plus B giving you C, okay, here say that if it is A, we have the concentration 550 initially, okay. Now it is reacted about 3 and it is reacted about 1 and it is found about 1 only, okay, or maybe we can say 2, but at t equals to 0, at t equals to 1, but at t equals to t equivalence, it will have 2.5, it will have 2.5, and it will also form 2.5. So here the concentration of that two reactant arsen, that point is called equivalence point, okay. We can refer to that equivalence point as a t equilibrium also. Now, endpoint, point at which the reaction is observed to complete. This point is usually observed when the help of indicator. What I mean to say that if it is 0, it is 0, it is giving 5. Now we have no reactant site and only the product site, so no chemical reaction can occur after that because the endpoint has achieved. So that is the endpoint basically, okay. Now, what are the, okay, some terms are related to this also. Concentration terms. So how we will check concentration? Basically molarity, normality, okay, or molality also, smaller. So I have not written all this thing because you have heard about that terms in the mole concept chapter. Okay, some apparatus is there and some types of titration also there, that acid base titration, complex geometric redox precipitation. You also have heard about that. Okay, so I'm showing you some apparatus like this. It is a beaker, this is a pipette, 20 ml of acid solution which is given. Now it is taken there and it is a burette. Standard NaOH solution is generally flowing down uh, with proper weight and proper measurement, okay. And all this, now this, see that as NaOH goes down, the color of that acid solution generally changes. That is generally acid base reaction, acid base reaction basically, okay. Simple, I have taken. Now we have seen most of the things. I think I have completed almost all part. Now let's move on to some previous year questions. Previous year question, because only the questions will asked in the chapter, and we should have the knowledge how what type of questions are asked, because it is a mostly a theoretical part, and it is somewhat a chemical, so somewhat a complex questions part also, okay. We will see. Now what is the first question says, okay, I think it is visible. Let me zoom in somewhat. Okay, it was visible, okay. Now, question number 1 says that Michel's scale measures the mass of object as consistently 2 kg less than their actual mass. How would you describe the scale? Okay, so it is saying that there is a defect in their scale instrument or whatever he or she, okay, Michel's, so whatever he is using. So it is saying that how do you describe the scale? See, it is generally, see, it is a 2 kg, but it is showing less than 2 kg. So let's see the option. It is neither accurate nor precise. It is precise but not accurate. It is accurate but not precise. It is both accurate and precise. So my answer to the question will be it is precise but not accurate. Okay. We are getting the answer, but it is not accurate now. So it is precise but not accurate. So question number 1 answer comes. Question number 2. See, it is a logical question for most of the question, most of the students. Now we will jump on to the question number 2. Question number, I am writing the answer here. Question number 1, it is second. Now we will check for question number 2. What does question number 2 says? Which of the four, see, as this is a chemistry part, so you just need to understood that if you know the concept and if you know the answer, then you don't need to do any calculation in your mind also. Just you need to recall or recite what you have learned, what you have studied, because the chemistry is about, if you know it and if you hit it, you generally mark with a within a second. So chemistry is also a marks giving subject, okay. Now, which of the following substance cannot be separated by the distillation? Okay, you all know about what I mean to say, that what the question is asking about. Distillation process, you have learned fractional, simple, okay, all that. Now, a mixture of proteins, crude oil fractions, oxygen and nitrogen in air, and water in salt solution. So which is not possible? Okay, so the answer to that question is a mixture of proteins cannot be separate. Okay, so in that chapter also you have also studied that we can separate crude oil also, that petroleum or refinery. Okay, now oxygen and nitrogen in air, we can separate this one also. Water in salt solution, it is no doubt that it can't be separated by distillation process. But the mixture of proteins, it cannot be separated with the method of distillation. So question number 2 answer is 1, that is A. Okay, I will mark this A and B. Now moving on to question number 3. Which of the following separation technique is dependent on the difference in the volatility? Okay, you all know what is volatility. Okay, now first one is distillation, second one is crystallization, third one is magnetic separation, and fourth one is fractional distillation. Okay, so which of the following separation technique is dependent on the difference of volatility? So we need to check that for if we are giving two substances and both of them contain like if hydrogen or see that if we have a alcohol, it is contains a more volatile than if water. Okay, water and alcohol. So which method we will use? So the distillation process is mostly dependent on the volatility. Okay, so this one is only dependent. So question number 3 comes from A only. Now question number 4. Okay, these are some theoretical questions. What is the use of TLC and HPLC? Question number 4 I am writing. Question number 4. Okay, I will not write whole answer. I will just give the intro and you may proceed. So the basically TLC, if you have studied, TLC is used to check whether the reaction is completely or not. Okay, to check if reaction is completed or not. On the other hand, HPLC, it refers to the or it is used to identify the quantity, used to identify the quantity or to separate the mixture. Okay, now question number 5. Question number 6, what it is asking, what is added to the iodometry and ideometry? Okay, ido, these both are different terms and don't fall in that case. Iodometry and iodimetry analysis in the rate of saturation. Okay, I generally confuse about that meaning, so that's why I'm marked that iodo and iodimetry. Okay, so for iodometry, iodine. Okay, let me write here also on iodimetry. Okay, what does the iodometry say? For iodometry, the element iodine is added to starch solution. Okay, you know that the entire titration we use starch. Okay, solution in the one of the example. Okay, and the endpoint is signaled by the change of color from a colorless solution to a blue color. Okay, and we see the end point by seeing the color change. Okay, how it is changes from colorless to a blue color like this. Okay, now question number 6, what it is asking? Question number 6 is saying what are the differences between qualitative and quantitative analysis? Okay, so I will not give answer of this question. I will just say question number 6, refer slides. Okay, you can just pause my video and check back if you have any doubt. You can see that I have described what is qualitative and quantitative. Okay, uh, for a review, I can say that qualitative is mainly for describing the quality of that product form, okay, or the reactant used, and quantitative we check how much more. Okay, that two words I have seen that. Now question number 7, what are the differences between molarity? Okay, I'm skipping this question also. Mole concept, you can see mole concept. Okay. Now, question number 8. Question number 8. What it is asking? Okay, some units are there. Okay, let's see. This one is kind of easy question. If we check on the first one, that is molarity. Okay. So molarity, mole fraction, mole, molality, pressure. Okay. See, all I have learned the chapter, or I think that all have studied that mole concept chapter are very familiar to you, and you are comfortable with this chapter. Okay, this all these questions are come from there only, but just I have added this so that titration part involves this some of this units also. Okay, so what about molarity? It is moles per liter. A is fifth. Now, what about mole fraction? It is mole to mole only. So the option is B because it doesn't give any unit. Now, what is mole? Mole is generally mole per kg. Okay. Now, what is molality? Molality is okay. Sorry, I think I have. Okay. This one is this, and molality was this. I was confused. Now, pressure is Pascal. Everyone knows. Okay. Now, moving on to question number 9. What is question number 9 saying? Okay, some relation is given. Now, 88 gram of CO2. What is 88 gram of CO2? So, it is the if you divide 88 gram by the molar mass of the CO2, it will give 1 mole, and 1 mole contains 6.022 into 10 to the power minus 23 molecules. Okay. Now, what about 6.022 into 10 to the 3 molecules? Okay. It is giving you 3 moles. You can check it. So you can do all these questions by your own also. So I am just skipping all this 3 part. Okay. Okay. Now let's move on to the next question. That is question number 10th. Okay. What the question number 10 says? Okay. Let me just move it up. Okay. And add it to the narrow. Okay. Question number 10 says, what is the use of ion pair reagent? Ion pair reagent. So basically, the ion pair reagent refers to the chemical substances that pair each other to form complex or ion pair reagent. What I mean to say that chemical substances that pair each other to form complexes are ion pair reagents. Okay. And this can be used to stabilize one of the more active molecules to clarifying or other properties, etc. Okay. Now let's what many theoretical questions come. Now let's see one of the calculation part of the question. Okay, so let's read it. A reaction between 1 mole of sodium and 1 mole of chloride should yield 42 grams of sodium chloride. Okay, in your experiment the actual yield is this one given. Calculate the percentage error. Okay, we have to calculate the percentage error. See, so we have given theoretical yield as 42 gram. Okay, and the actual yield which it is asking is 32.73 gram. Okay, now what is percentage error? Percentage error is basically theoretical yield minus actual yield divided by theoretical yield into 100. Okay, this formula I think you have seen in mole concept too. Okay, if not, just write it in your any wherever you make the short notes. Okay, now what is that? 42 minus 32.73 divided by 42 into 100. Simple calculation. Okay, so it will come approximately, percentage error is approximately 22.07 percentage. Okay, so I think this is okay for today. So we have seen the some of the questions related to the quantitative, analytical chemistry, and you can practice more and more questions on this chapter also from Google, or you can check any other books also. So for this, at this, our chapter ends here, and practice more. Okay, thank you all of you. We will meet in next lecture. Bye bye.